Hi there. Today we're going to look at solving equations involving natural logarithms. So looking at e and ln, and basically all the same rules hold. So all the rules you've used for logs, all the ways you've solved things using logs, everything still holds. We're just using this base of e. The thing though that I need to highlight is the word's exact form. So basically what you're looking for here is something that's not a rounded decimal. As soon as you start rounding anything, you're not exact. You're looking at an approximation. And there's a couple of little things within these questions that I want just to highlight. So for example, if you had a question that said e to the 2x plus 3 is equal to 7. Now the way I approach those is I think, okay, I need that power down. So I'm going to take logs to both sides. Because I've got this power of e, I'm going to use log to the base e, so that's ln, so I'm going to take ln to both sides. So I've got ln e to 2x plus 3, and then that power is going to come down. So I've got 2x plus 3 times ln e equals ln 7. Now I just want to highlight this bit here, because this is log to the base e of e. So this is saying what power of e is e? So that is 1, because e to the power of 1. So this question becomes 2x plus 3 is equal to times 1, which I'm not going to bother putting there, is equal to ln 7. So x is equal to ln 7 minus 3 over 2. And that is exact form. Now you will notice that I went from here to here. And as a sort of shortcut way of thinking, although I've gone through the exact reasons, you could say that ln undoes e. And that's and vice versa. So taking that just a little bit further, if I had a question that said 2 ln x plus 1 is equal to 5, I would say, rearranging that, I've got 2 ln x is equal to 4. So ln x is equal to 2. And then I would take e to both sides. So I've got e to the ln x is equal to e to the 2. And over here, ln undoes e and vice versa. So see, e and ln undo each other. So I'm just left with x is equal to e to the 2, or e squared. And again, that's an exact form. Although e is irrational and transcendental, that's the most exact way of writing it, because otherwise we're doing rounding. And the final example that I just want us to make a start on, e to the 2x plus 5e to the x plus, sorry, equals 14. So clearly we're looking at a quadratic. I would rearrange my writing of this slightly, and I would say that that is e to the x squared plus 5e to the x minus 14 is equal to 0. I might make a substitution there just to make it a little bit easier. Let's say y equals e to the x. So I've got y squared plus 5y minus 14 is equal to 0. So I've got y plus 7, y minus 2 is equal to 0. So y is equal to minus 7 or 2. And then just polishing that off, so e to the x is equal to minus 7. For taking ln to both sides, I get x is equal to ln of minus 7. And actually that doesn't exist. If you look at the graph of ln, it comes just like, how's it go? It comes like that. So there's no ln for negative x. So you can't ln of a minus anything. So that doesn't exist. So we have to disregard that, but it's important to look at it first. So, e to the x is equal to 2. So taking ln to both sides, ln of e to the x is just x equals ln 2. So even though the quadratic implies that there's two answers, there's actually only one answer because one of them doesn't exist. You can't, and what you should know, this is a positive number. I can't take a positive number to something else to get a negative number. That just would never work. And if you think about the graph of e to the x, it's always lifting up from the 0 axis as an asymptote at 0. So few things here. Ln and e undoing each other. When you see that word's exact form, we don't work them out. We just leave it as ln and leave it as e. And okay, spot the quadratic. There's going to be loads of questions like that. And that little substitution often helps people. Okay.